Hello everyone, today we're going to do a problem related to the Coulomb's law. We have four positively charged particles on a circular ring as shown in figure, and a particle with charge q is placed in the center of the ring. Since all charges are positively charged, they will repel each other. We need to figure out what will be the net force experienced by the charge at the center of the ring. Let me redraw the diagram, which looks something like this one. Let us do the things step by step. Let us first figure out what F1 is. If you look here, force F1 is pointing towards the negative y direction. So the direction will be the negative y cap, where y cap is the unit vector along the y-axis. The magnitude of this force will be given by the Coulomb's law. So that will be equal to k times 2q divided by the square of the distance between them. Here I have assumed that is the radius of the circle is r. We now have the force F1. Let us figure out what is the force F2. So, if you look here, if this angle theta is 30. So, this will also be 30. Now the force will have both x and y components, so we need to figure out both x and y components for F2. If this angle is theta, the x component of the force F2 will be F2 sine theta, and the y component will be F2 cosine theta. Since the x component is in the positive direction, it will be plus x cap, and the magnitude is again given by the Coulomb's law, k times q divided by r square, and we need to multiply it with sine 30. Similarly, we need to write the y component here. The y component is in positive direction, so I have the positive y cap. And again, the magnitude will be k times q divided by r square, and we need to multiply it with cosine 30. So let me further simplify this one. F2 will be equal to positive x cap times kq by r square, and sine 30 is 1 by 2, plus y cap kq by r square, and cosine 30 is square root of 3 by 2. Let us now figure out what the force F3 is. F3 is pointing in the positive y direction. So it has no x component. F3 will simply be given by positive y cap kq by r square. Let us figure out what the force F4 is. If this angle is 30 degrees, this angle will also be 30 degrees. Now again we need to figure out the x and y component of this force. If this angle is theta, the x component of the force F4 will be F4 sine theta, and the y component will be F4 cosine theta. Since the x component is in the negative x direction, it will be negative x cap, and the magnitude is again given by the Coulomb's law, kq divided by r square, and we need to multiply it with sine 30. Similarly, we need to write the y component here. The y component is in positive direction, so I have the positive y cap. And again, the magnitude will be kq divided by r square, and we need to multiply it with cosine 30. So let me further simplify this one. F4 will be equal to negative x cap times kq by r square, and sine 30 is 1 by 2, plus y cap kq by r square, and cosine 30 is square root of 3 by 2. We have now all the forces acting on the charge q at the center of the ring. So, the net force will be the sum of all the forces acting on q, which is F1 plus F2 plus F3 plus F4. What we need to do now is, we need to collect all the x and y components separately and add them up. Let me do first the x component. Only the force F2 and F4 have x component, as you can see in the blue circle. They have the same magnitude but the opposite sign. That means x component of the net force will be 0. Now let us do the same for the y components. We have four y component terms to deal with. Here if you look, all the four terms have kq by r square term in common, so, I can pull that term over here. And the remaining terms from F1 is minus 2, from F2 is square root 3 by 2, from F3 is plus 1, and from F4 it is square root 3 by 2. If we further simplify it, we will get 0x cap, plus, kq by r square, times square root 3, minus 1, y cap. If you go back to the problem statement, what it is asking here is, what is the direction and magnitude of the horizontal and the vertical force experienced by the charge at the center? Thus, we can conclude that the magnitude of the horizontal force is 0 and the magnitude of the vertical force is kq by r square, square root 3 minus 1, and it is in positive y direction.